Solar DC cables, is 500 volts versus 1500 volts real or just marketing gimmicks? Let's settle something in solar installation once and for all. Some people sell DC cables like this. You see this one is 500 volts. You see that one is 1000 volts. The one we put up there is 1500 volts. So choose which one is better for you. And immediately the price varies and it changes based on the voltage ranges. But here is the real question. Is cable voltage rating actually the most important thing in solar systems, or is it something people are using to confuse customers nowadays? Let's go deeper. What standards actually say? In real electrical engineering standards like the IEC 62930 and IEC 60228 cable classification, cables are not selected mainly by voltage marketing labels. They are selected by the current carrying capacity, which is the ampacity, the insulation class, the temperature rating, the installation condition, whether in the roof, whether in conduit, whether in trunking, or whether the cable will be buried, the UV resistance for solar exposure, and the copper conductor quality. Voltage rating is present, yes, but it is a design limit for insulation safety, not a performance upgrade. So yes, cables do have voltage ratings, but no, that is not what determines how good or strong a solar cable is. I repeat that. Yes, it has voltage rating, but it doesn't determine how good or strong a solar cable is. What 500 volts or 1000 volts really means. Let's simplify it. A cable rated 500 volt DC, 1000 volt DC, 1500 volt DC is basically telling you this insulation can safely withstand this level of electrical stress without breaking down. That is, it does not mean higher power capacity, better current handling, better efficiency, lower losses, none of that. So the marketing idea that 1500 volt cable is stronger is incomplete. Stronger for what? Only insulation breakdown voltage. Why this confuses many installers and customers? In solar markets, especially informal distribution channels, voltage rating becomes a pricing tool. So people say, take 1500 volt cable, it is premium, but they rarely explain the copper purity, the cross-sectional area, the temperature rating, the UV resistance, the real ampacity at rooftop temperature. So the customer is made to think higher voltage number equals to better cable. But in reality, higher voltage rating does not automatically mean better cable quality. Now, what actually kills solar cables? Now, let's be practical. Most cables failures in solar systems are not caused by voltage rating. They are caused by undersized cable carrying too much current, high rooftop temperature, poor termination, that's loose lungs and loose terminals, cheap copper or aluminum mix, UV degradation from poor insulation, bad installation routing, that's when there is no ventilation and you didn't account for that. So the real danger is heat plus current overload, not voltage label. So what is true cable quality, you are now asking? If you want to judge a good DC solar cable, ignore marketing first. Look at this, the copper quality, pure copper, not mixed or low grade conductor. 2. Cross-sectional area, the square. This determines current carrying capacity. 3. Temperature rating. Good solar cables handles between 90 degrees Celsius to 120 degrees Celsius. 4. UV resistance, important for rooftop exposure in Nigeria and similar climates. 5. Certification. This might be dicey, but you can still watch out for the IEC or TUV standards. It matters more than the voltage marketing gimmicks. Now, fact checking the voltage and quality claim. So let's be direct. Saying 1500 volt cable is better than 500 volt cable is, number 1, incomplete, 2, misleading when used alone, and 3, not a measure of cable performance. It only becomes meaningful when discussing large solar farms, that's high string voltage, utility scale, that's PV systems, large utility PV systems. But for smaller or medium solar systems, both may even be overrated. So the truth is, voltage rating is a safety insulation spec, not a quality ranking. Simple way to explain to customers. If someone tries to overcharge you using voltage rating, ask this: what is the current rating per square at rooftop temperature? What is the copper purity level? What standard is this cable certified to? What is the temperature and UV rating? What is the actual installation condition it is designed for? Can it be designed for hot roof, inside roof, or in very, very severe condition? Because serious engineering is not based on one number alone. My final lesson, let's close it in a very simple way. Solar DC cable quality is not defined by whether this cable can carry 500 volts, 1000 volts, or 1500 volts. Those are insulation limits. Real cable performance is defined by the current capacity. That's very, very important. The heat resistance, the copper quality. Hope it is not mixed with aluminium. Insulation environment, the certification standard may not really hold much water in Nigeria, but you can still watch out for that. So don't let marketing turn engineering into confusion. In solar work, the cable that survives heat, current, and time is the real premium cable, not the one with the highest voltage number. So anytime anybody try to push you through the voltage gimmicks, tell them that you are not buying it and you are simply going for the one that can actually handle the current and the heat and the temperature. Thanks for watching. Do like, share, and subscribe.